All right, dude, we are live. What's up, guys? This is Dem Keys, and today we're going to be taking a hopefully short detour because I got a little bit distracted with something. Today's distraction, or let's say the recent distraction, is Altair. I don't know if they intend for it to be pronounced as Altair or Altair. I'm going based off of what I believe was a video game system or a computer system back in the day. Give me a second. Oh, actually, you know what? We can start. This is so stupid, but this is something that I focus on. So at least to me, it's not stupid because I wanna know how the thing is pronounced. So okay, Altair for now until I learn the actual pronunciation. Altair is a data visualization library. And I found out about this. I'd actually heard about Altair in the past when I was looking for various matplotlib alternatives. And I did see Altair being mentioned along with other libraries like Plotly and ggplot and various other tools. Um, where was I going with this? Yeah. So recently I started learning polars, and even though, unfortunately I put that on hold, the great thing actually is that I feel like, okay, so unfortunately I put that on hold after doing it for a little bit. I'm not done learning polars, not by a long shot. I barely even finished the basics. So I need to, at the very least, finish the basics and then start doing, exercises and problem solving and stuff with it. Um, Give me a second. Let me open up my stream on my phone so I'm able to look at my chat. Now, um, where was I going with this? So polars. I was saying that, unfortunately I did step away from polars after starting it recently. I'm going to be getting back to it. However, I very strongly believe that I'm going to have an easier time picking polars back up than I did back in the day picking pandas back up. And that should tell you something about both of these libraries and the way that they're designed, the way that their APIs are designed. I'm confident enough, being a beginner, a complete beginner, being basically the B in beginner, forget about the rest of the alphabets. Being the B in beginner of polars, I'm still confident that I'm going to be able to pick polars back up much easier than I had to pick pandas back up back in the day. Because there were situations where, I wouldn't use pandas for, a certain period of time. And so I would forget how pandas works and the various functions, the ways of accessing things and various, rules of how data frames work in pandas and stuff like that. I would forget a bunch of those things and I would have to relearn them again. Um, Okay, back to Altair. I'm gonna ask this question. So, hey, I recently started learning. No, I recently found out about the Altair um, DataViz library, and am gonna start learning it soon. Um, is is Altair pronounced A double L? I'm trying to do the phonetics thing. Hold on. Pronounced. There. All T air or al T air. It's generally pronounced Altair, rhyming with hair and stare. The first syllable sounds like the al in album or alpha. Oh, okay. The library is named after Altair, the brightest star. Oh, okay, Altair, the brightest star in the constellation. Aquila, which follows the same pronunciation. You're gonna love working with it, uh, because it's a declarative library, meaning you describe what you want the visualization to look like rather than writing step-by-step code to build it. It makes creating complex layered charts incredibly intuitive. Okay, yeah, I'm actually excited about that because I was having a conversation with Gemini about this, and I was trying to compare it. So I mentioned that I recently started learning polars, and I'm going to start learning what I now know as Altair. I'm going to start learning Altair soon, but I was wondering, because I'm coming from a pandas plus matplotlib background, what would the polars plus Altair workflow be like? And more specifically, I'm trying to understand matplotlib versus Altair. And it turns out in matplotlib, you tell the library how to draw, whereas um, in in matplotlib, you tell the library how to draw it, but in Altair, you apparently just tell it what to draw. You describe what you want to draw, and the rest is taken care of for you. Now, what that means in practice, I guess we'll find out. We won't be digging too deep into it, but I am having a couple of conversations with Gemini about this. So we'll learn whatever we can when it comes to Altair. Give me. I'm trying to look for the old Altair thing because I remember people pronouncing it as Altair, and I'm wondering if I got it wrong or they got it wrong. Okay, that's interesting because um, I was trying to go off of the pronunciation of the, hold on, I messed up the spelling of pronunciation, uh, of the old computer system, Altair, and from what I remember, it, let's say people were pronouncing it as all T air. Were they wrong, or is this just a different pronunciation? Okay, you're actually completely right about your memory. A lot of people back then, including the engineers, hobbyists, and early tech builders in the 1970s, did pronounce the Altair 8800 computer as Altair, with that all sound at the start. It isn't a case of one being definitively wrong. Rather, it's a classic linguistic split between dictionary slash astronomical pronunciation and the regional American accents in the era. Here's what happened. Hold on, I need to choose one of these responses. So I'm just gonna. Okay, here's what happened. The star pronunciation, the word comes from the Arabic al Nasr, al Tair, Al, is it Nasser or Nasser? Okay, anyways, Altair, meaning the flying eagle. Okay, so it's not even Altair, it's Altair. Okay, okay. In standard English dictionaries, it is transcribed as al, short like alligator, Altair, Altair. Okay, it the 1970s tech pronunciation. The MITS Altair 8800 was created in Albuquerque, New Mexico. Um, in many American regional dialects, especially when reading a word starting with AL followed by a consonant like, um, I'm not sure how to pronounce that, almanac, alter, that's one. Okay. And then there's also alter, which means to change. The first altar was um, the church kind of thing. Okay. The natural impulse is to pronounce it with the open all sound. Because it was a hobbyist machine talked about at local clubs like the Homebrew Computer Club, rather than on national television, the Altair pronunciation stuck hard in the tech community. The verdict: if you are talking to old school computer historians about the machine that launched Microsoft and inspired Apple, Altair will sound completely normal and period accurate. But if you're talking to modern data scientists about the Python library, you will mostly hear Altair. You know what? That's good enough for me. So we're going to stick with Altair for now. Actually, moving forward, not for now. Okay, so we are learning about Altair. Um, so the conversation I was having with Gemini about this was I first asked. So there were two things. First, I wanted to learn about Altair. That's one, right? But then while doing the research on Altair, I learned about this thing called interchange protocol. And so I started doing research on that. And this is a very interesting topic because it seems like this is the intermediate representation. I'm still reading up on it, but this is what I'm getting so far. This is the intermediate representation of a data frame, um, because of which, if your library or if any library knows how to read the intermediate representation, then any data frame that supports that intermediate representation can be read from the library. So, just to put it practically, something like matplotlib, in terms of data frames, it mainly accepts pandas data frames. Um, Something like Seaborn, which is built on top of matplotlib, it doesn't natively support Polar's data frames. I don't think it natively supports pandas as well either. There's even matplotlib for that matter. There's certain functions you have to call in order to have it be supported, but this support had to be coded in, right? So there has to be explicit support for so and so type of data frame. That's one way to go about it. But if your visualization library supports the interchange format, then any data frame that can convert to that implements that interchange format, your visualization library would then be able to read that data frame very easily. And this I found really interesting because this basically becomes like a serialization kind of thing, right? You take JSON, for example. JSON can help two different programs talk to each other as long as they both speak JSON. So one knows how to write in JSON, but yeah, write to JSON, and the other knows how to read from JSON. This basically becomes that kind of situation, and that is actually really useful because this way, visualization libraries or any library that's planning on using data frames in general doesn't need to add in explicit support for specific data frames. They can add in support for this interchange format, and as long as the different data frame libraries or data handling libraries or data processing libraries, whatever pandas and polars type of libraries are called, as long as these types of libraries implement support for that interchange format, any other data visualization library that understands the interchange format can also understand any one of these different types of data frames. So the devs will only have to implement support for the interchange format rather than having to implement support for pandas separately, polars separately, and then whatever XYZ other data frame data frame library comes along, rather than having to implement support for each of them explicitly, you can just have this intermediate representation that you need to implement support for. So this is my understanding so far, but I still want to get like a proper understanding of this. So okay, Gemini was explaining the core concept here. In the past, if a library like Altair wanted to plot data, it had to explicitly support pandas. If it wanted to use a different data frame library like polars, Altair's developers, I have to work really hard to forget that Altair pronunciation and say Altair instead. Anyways, if you wanted to use a different data frame library like polars, Altair's developers would have to write custom code to convert polars into pandas first, or you would have to constantly type .2 pandas in your scripts. The interchange protocol solves this by acting as a universal translator for tabular data. Instead of instead of every library needing to know about every other library, they all just speak the protocol. So data providers um, like Polars, Pandas, and cuDF implement a data frame method, and data consumers like Altair, scikit-learn, etc., read from this method without caring which library generated it. How it works under the hood. When you pass a Polar's data frame directly into an Altair chart, Altair doesn't see a Polar's object. It sees a standard. Speaking of Altair, hold on. In terms of visualization, or for the sake of aesthetics, let's show this instead of the other thing. And I actually want to explore each and every one of these. I looked at the examples, not examples. I looked at the GitHub actually, and there I saw one example, and the API seems very interesting. This seems like one of those. I feel like if I explore Altair more, then the same way how I thought Polars has a very ergonomic API, I feel like I'm gonna get the same feeling from this as well. That it's a very ergonomic API. Because if you look at stuff like this, for example, I don't fully understand what a lot of this is, but looking at the way that these calls are being done, like you have this chain method sort of thing going on, and then there's uh, the whole like descriptions thing, where you are describing what the data is supposed to be rather than explicitly trying to control how the library draws things. I feel like libraries like Matplotlib and Pandas, they are, I'm not going to say a thing of the past, but they were a huge part of the past. They were the biggest players in the past, and because there weren't better tools or different tools like other options being either developed, or if they were developed then being widely supported, it just because we didn't have, or a lot of people didn't have other options at the time, so they stuck with pandas and matplotlib. And both of these libraries are very, very mature libraries because they've been around for, um, I would say, more than a decade. I'm pretty sure they've been around for more than a decade. So they've had a lot of time to mature. They've had a lot of time to have various features added to them based on what the community needs, and they've had many years of bug fixes and optimizations and stuff like that. Um, what was I saying? Yeah, I feel like these libraries, Pandas and Matplotlib, both of them have had many years of work put into them. But because these are older libraries, and back in the day they had a different way of doing things, so it's not the easiest thing to like change the foundation of a library. If things have been done in a certain way, like the base, the foundation of it, if things were done architecturally in a certain way, just ripping out that foundation and replacing it with something else is not the easiest thing to do without breaking a bunch of functionality, and breaking, a bunch of other libraries that rely on these libraries. And there's a lot of libraries that actually have support for pandas and matplotlib and other such mature libraries out there. So it's not the simplest thing to do. And in a way, that has been a good thing. In a way, that has also kind of been a bad thing, because that's why you end up with an API like Pandas API, which when I compare it to Polar's API, Pandas API seems like a nightmare. Like if you compare, this is why I call Polar's API an ergonomic API. It's because it feels like natural language, if that makes sense. It feels a lot more natural, in terms of what you are trying to do, what actions you are trying to take, what actions you have to take in order to accomplish certain goals. It seems a lot more natural, a lot more of a comfortable API. Meanwhile, the Pandas API, it requires you to do all sorts of very ugly things. I have no idea how to describe it and what would be a good example, but having worked on complex projects with Pandas, I would say the Polar's API is, I like Polar's API much more. Um, Granted, I haven't done a very complex project with the Polar's API, but I have done a couple of different types of projects with the Pandas API. And we have a similar situation with something like Matplotlib. Matplotlib is amazing because you can customize a lot. You can make highly customized visualizations, plots, graphs, even animations. There's a lot that you can do with Matplotlib. The problem is the API requires you to know to a certain extent how things work on the lower level. They give you access to a bunch of the lower level things, so you can customize it. Um, but because of that, and because of how their API is, if you do want to customize things, things get very complicated very quickly. And I know this because I've tried to do customizations in Matplotlib, and these weren't even like very complex customizations, but they were very specific things. They needed the data to be presented in a certain way, and we had to only pull out certain types of data, not all of it. We had to like maybe format the data in a certain way. There were certain requirements there, and that required me to do research on how various components in the plot work, and then how I can customize those components, because even the customization of those components has a certain way to go about it. um, and I feel like these kinds of libraries, like Polars and Altair, they solve the problems that people would run into with pandas and Matplotlib. Now, I could be completely wrong about this because I haven't explored Altair and I've explored Polars very little. And from what I did explore, I liked what I saw. I guess we'll find out once I start doing more complex things with it. Okay, let's continue reading this. So, how it works under the hood. When you pass a Polar's data frame directly into an Altair chart, Altair doesn't see a Polar's object, it sees a standardized representation of memory. The protocol defines a blueprint for describing chunks, which is how data is split across memory, columns, such as names, data types, and validity masks, and buffers, which is the raw data underlying the raw, the raw underlying memory pointers where the data actually lives. Okay, because it passes memory descriptions rather than copying the data itself, it is incredibly efficient and avoids massive memory overhead. I can see that being a thing. I am curious about how we are creating an intermediate representation of this data, yet we are not necessarily copying the data. This intermediate representation, it just contains pointers to the data. So then Python knows, or whatever the underlying mechanism is, knows where to go and read that data. It's not necessarily copying the data. So it's not like it's an intermediate representation in that it's a new intermediate representation within memory itself. It's not necessarily something that you can export. Okay, because you're pairing polars and Altair, the protocol gives you a massive quality of life upgrade. One, zero copy plotting, mostly. When you pass a polar's data frame to Altair, it can read the memory directly. You don't have to duplicate your data set in memory just to visualize it. That is actually very powerful because if you have small data sets, it's not a very big deal. But if you have data that has rows that's in, hundreds of thousands or even in the millions, you really don't want to be making copies of this kind of data just so you can do something with it. If you are able to operate on the data exactly where it is in memory, and just you're just jumping around using pointers, that ends up being a lot more efficient and a lot faster than creating a whole copy of a massive, data set, a massive chunk of data, which would then take time and also increase your program's memory usage. Um, okay, then there's the no more dot two pandas. So the two pandas function, I'm assuming that converts the data frame into converts the polar's data frame into a panda's data frame. Your code stays clean. You can do all your heavy lifting in polars and drop it straight into Altair. Future proofing. If you ever need to scale to GPU accelerated data frames like cuDF or distributed data frames like Modin, I haven't explored either of these. Altair will accept them just as easily because they all implement the same underscore data frame protocol. Okay. Um, all right. So I kind of understand what's going on here. Give me a second. Yeah, I kind of understand what's going on here. Uh, if I'm if I'm getting this right, um, we are basically actually not we. The libraries, the data providers implement a method that provides a sort of intermediate representation of this data, and and then the data consumers only need to know how to use that intermediate data, that intermediate representation. And because it's implemented by, hold on, I spelled implemented wrong. Implemented by multiple data providers. Any data consumers that understand that intermediate representation um, could then read data from all those different data providers. Is that right? I feel like I get it, but also don't fully understand because it's not like, no, not but, because it's not like this data is actually being serialized completely to a different form, kind of like data to JSON and Rust to LLVM IR. It's more so an intermediate representation in memory. It's just that the data frame method being implemented is what presents the data set as that intermediate representation, right? Is that also why we don't have copies of data copies, but rather just have pointers to the data? Okay, spot on. You have actually grasped the core concept beautifully. Your distinction between serialization, like JSON or LLVM IR, and a shared memory representation is exactly the right mental model. To bridge the gap between kinda understanding and fully nailing it, let's break down exactly what is happening in memory. It is a virtual, quote unquote, virtual intermediate representation. Okay, that's a good way to put it because we don't actually have a representation of it, right? So then virtual would be a good term to use there. Man, looking at all these plots and shit, I kind of miss doing data science stuff. Holy shit, dude. We like branched out big time. I remember I was doing the Kaggle stuff. I still intend to get back to, doing the Kaggle stuff and finish all those courses and stuff. Um, but it's more so just for playing with data and maybe also doing data science stuff. Because um, keeping aside just machine learning and robotics, I feel like learning data science, it helps me understand data and pull useful information out of data for many other situations other than just machine learning and robotics and stuff like that. I feel like there's plenty of other situations where, given the adequate amount of data and the right tools, and the right knowledge, whenever I finish learning all the stuff that I'm trying to learn, given the right tools and the adequate amount of knowledge, I would be able to transform data into something useful. I would be able to extract useful information from data, from even from data that has a bunch of noise in it. I don't know if what I just said makes any sense, but yeah. Okay. You are entirely correct. There is no translation step where Polars converts data into a new physical format. Instead, instead of an intermediate data structure, think of it as an intermediate interface or API blueprint. Okay. When a data consumer like Altair asks for data via the protocol, the data provider like Polars doesn't hand over a new block of memory. It hands over a specialized Python object, um, a data frame capsule that says, hey, I'm not going to move my data, but if you look at pointer A, you'll find the 64-bit floats for column X. If you look at pointer B, you'll find a bit mask showing which of these rows are null. The intermediate representation, quote unquote, is just this standard metadata wrapper around is just this standard metadata wrapper around the existing memory. Why this enables zero copy? Yeah, because it's pointers, right? Your intuition about pointers is 100% correct. This is the magic of the protocol. In a traditional setup without a protocol or without the protocol, if you wanted to move data from polars to another library, Python would often have to allocate. And wait, let me read that again. If you wanted to move data from polars to another library, okay, Python would often have to allocate a brand new chunk of RAM, read the values from polar's memory, and then serialize/write them into the new RAM allocation. With the interchange protocol, because the data provider exposes the raw memory addresses, which are pointers, and describes exactly how the bytes are laid out. Example, every 8 bytes is a new integer. The data consumer can point its own internal machinery directly at the exact same RAM. Two different libraries looking at the exact same physical chips in your RAM stick without a single byte being copied. The catch, when copies do happen, while the goal is zero copy, you will occasionally hear it called zero copy mostly. This is because libraries store data differently under the hood. You have Arrow versus block managers. Polars uses Apache Arrow under the hood, so data is stored strictly column by column. Older versions of pandas used a block manager, grouping all float columns together in one big block, all ints in another. Okay, so this is the underlying implementation, how it is being, because you often don't need to like think about this when you're working with pandas, like the fact that all floats are grouped together, all ints are grouped together. This is the internal representation of it. The pandas API, it kind of abstracts all that away from you. It gives you a high level API to work with. So you're dealing with the higher level stuff, but on the lower level, the library is still handling all of these very complex things for you. Okay, the reconciliation. If Altair, or rather the backend library it uses to parse the data, expects the memory to be laid out a certain way, and Polar's native memory layout matches it perfectly, it's 100% zero copy. If there's a fundamental mismatch in how the two libraries expect bytes to be aligned, the protocol allows the consumer to say, I can't read this layout natively. Please export a copy for me. Even when a copy is forced, the beauty is that the interchange protocol handles the negotiation automatically behind the scenes, saving you from writing the glue code. Okay, okay, so I'm starting to understand this much better. So in practice, what does this look like? Polars implements the interchange protocol via an underscore data frame method, and that method returns an object that the consumer, the data, let's say that Altair knows how to read because Altair also implements the interchange protocol. You have completely nailed it. This is exactly how it works in practice. To look under the hood at the exact mechanics, Here is the dance that happens between polars and Altair when you pass a data frame into the chart. Practical mechanics. The handoff. When you write alt.chart df, Altair looks at the df object. It checks, is this a pandas data frame? If no, then it checks, does this object have um, does this object have a data frame method? Because it's a Polar's data frame, the answer is yes. So okay, I'm guessing Altair has native pandas support then. If it's checking first if it's a pandas data frame, it might have native pandas support. And if that support is not there, then it's going to look for the data frame method. Um, and then that data frame method is going to tell it how to retrieve the data. Okay, the request. Altair calls that method behind the scenes, effectively doing something like this. So it's what Gemini is showing here is basically the interchange object is being created by, well, I could paste the thing here. Do I have a Scratch file? I don't remember if I created a Scratch file. I probably did not. These are okay. This is hidden. Yeah, I probably did not. Okay, so let's do Scratch or one. How? Wait, how did it know that I wanted? Oh, it didn't know. It was just. Wait, let me close this. Um, there. This is where's this from? I don't know where this file is. Where did I create this file? Let me look in Yahtzee. So here we need to go back and back. Oh, it's right there. Why is it not showing up here? You're joking. Okay, fine. It's there. Um, right. So I was going to paste. This is basically what this is basically what it does behind the scenes, apparently. This is what Altair does behind the scenes. It just calls df.dataframe and then you get the interchange object. This interchange object is the quote unquote virtual representation we talked about. It isn't it isn't a new data frame. It's a lightweight tracker that knows how to expose Polar's memory structure. Wait, let me read that again because I read that out loud, but I don't think I understood it. The interchange object is the virtual representation we talked about. It isn't a new data frame, it's a lightweight tracker that knows how to expose Polar's memory structure. Okay, all right. Yeah, now I get it. The consumption. Altair passes the interchange object to its own internal parsing engine or a utility function like from data frame. Altair reads the metadata from the object, grabs the memory pointers, and pulls the data directly into its plotting engine. Let's see it in raw Python. You don't just have to take Altair's word for it. You can actually call this protocol yourself in a Python REPL right now to see exactly what Altair sees. I would need a Polar's function or a Polar's, I would need a words. I would need a Python project that has a Polar's, that has the Polar's library imported. So, okay, I need all of these. Let's create a new thing here and create, What did I do there? What did C just do? Okay, anyways. Right. I don't remember if I had installed I probably installed Zoxide after installing what do you call it? Okay. Let's go into Scratch stuff. Learning. Okay. Oh, polars. There it is. So let's create this. Let's do that. Paste. All right. Now, polars. Great. So let's create, no, let's activate the environment. Bin, activate, and then open up NeoVim here and restore the session. I don't know what it's going to restore here. Okay, it restored property. Great. And then we'll do the same thing here. Source, env. Can I just like redo? Let's not redo. Source, env, bin. Give me a second. There. Env, bin, activate. Okay. Um, right. So we have a Polar's data frame here. So let's. Oh shit, dude! I was doing the practice stuff here. I just remembered that. I need to go back to that. I need to go back to that prompt where I was doing all of these exercises to practice whatever I was learning in Polars. I was getting Gemini to generate the exercises for me, so I could practice whatever I had learned. Give me a second. Okay, right. So we have a data frame, and here, according to Gemini, interchange so and so. Okay, so you don't have to. Okay, 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 and then see what Altair does. Okay, so we're gonna call this interchange, or I. No, let's not do that. Interchange. Interchange. No, we could do inter. Inter df. Inter obj. Um, what was it? Df dot data frame. This converts a data frame object implementing the data frame interchange protocol. This, okay, convert to a data frame object implementing the data frame interchange protocol. Okay, cool, cool. I'll read up on this later on. I guess we don't need to specify anything, right? Because there are default values provided. I think we are good. Yeah. So let's print enter obj type. So Python 3.13 py01.py. Yeah, it says polars.interchange.dataframe.polars data frame. Sorry, zoned out. Um, okay, polars won't give you back a standard data frame. Instead, it outputs a specific protocol object. Oh yeah, I missed the. Well, no, I didn't miss it. What Gemini is telling me is that it'll be polars.dataframe.protocol dot um, polars data frame X. The exact class name varies by version, but it is explicitly an interchange object. Sorry, zoned out. Okay, from there, a consumer library like Altair can dig into the chunks and columns. Okay, okay, all right. Okay, so I feel like I get it for the most part. Um, I'm just not sure where to stop digging. Um, is it enough to understand that uh, the, let's say, okay, interchange protocol IP allows the data to be represented in a certain way, and then as long as a library understands um, that representation, it can use the data. I don't think I need to concern myself with how exactly um, the intermediate representation is being generated, right? You can absolutely stop digging right here. You have reached the perfect developer level understanding of the interchange protocol. To answer your question directly, no, you do not need to concern yourself with how the intermediate representation is generated under the hood. Unless you are planning to write your own core database or a brand new plotting library from scratch, let me read that again. Unless you are planning to write your own core database or a brand new plotting library from scratch, the exact mechanics of byte alignments, memory buffers, and bit masks are handled for you by the Polars and Altair maintainers. The quote unquote mental box to put it in. As a data analyst or data scientist, you can treat the interchange protocol exactly like an interoperability guarantee. Think of it like USB-C. You know your laptop, which, as an example, Polars has a USB-C port. You know your external monitor, which is Altair, has a USB-C port. You plug them together, and video data flows instantly. You don't need to know the electrical engineering of how the pins inside the cable negotiate voltage to use it effectively. What you actually need to keep in mind, instead of worrying about the low-level memory, Zainar, hello, hello. Hey, Abhi, hope today is going well. I realize I never asked your pronouns. What do you prefer? I appreciate you asking that. Anything works. Um, I'm gender fluid, so anything works for me. I appreciate you asking that. And welcome to the stream. Hello, hello. How are you doing? I'm okay. I have just been busy with um. So suddenly, I don't remember how I got on this topic, but I was trying to find out how you go about visualizing data using the Polars library, like which libraries have support for which data visualization libraries have support for Polars. Um, what was I saying? Yeah, yeah. So then I looked into it, and it turns out Altair is one of them. And when I was I so I'd never explored Altair, so I started exploring Altair, and then I learned about something called the interchange format, or sorry, the interchange protocol, and that's what I've been looking into um, all this time. Um, Finally, something close to what I know. I'm yet to learn polars, but it's the next step of things I should pick up. I'm not an expert in polars by any means. I'm like the B of beginners, if that makes sense. I'm not even like past the beginner stage, but I would still recommend polars because of solely because of the API. The moment I got into it and I started doing stuff with it, instantly I was comparing it to pandas because I've actually done projects in pandas, and I've had to use pandas for more serious stuff. So instantly I was like comparing what the API feels like, and the API in Polars feels so much more ergonomic. It is it's great to work with. Um, I'm planning on like getting back to learning Polars because I never finished learning the basics. I got busy with other stuff. Um, I'm looking forward to getting back to that. But also in terms of data visualization, I wanted to see what other options I have, and it turns out Altair is one other option, and it it doesn't do data visualization in the same way that, or rather, you don't use it as a developer. You don't use it in the same way that you would be using Matplotlib. With something like Matplotlib, you would be with something like Matplotlib, you would be defining what or how the thing is supposed to draw the plot. Apparently, with something like Altair, you mainly just describe what you want to draw, and it does the rest for you. To what extent this is true, I'm yet to find out because I haven't done Altair um, practically. But then looking at some of the code examples, I'm kind of getting that idea. Granted, even in Matplotlib, for simple plots, they do have, you know, functions ready for you. It's not like you have to do custom, custom charts for every single simple plot that you're trying to do. But then when you try to do more complex things, when you try to do customizations, that's when things get a little bit complicated. And that's why we had the need for libraries like Seaborn, which provide you with higher level functions um, that do a lot of the more commonly done tasks in data visualization. So I'm currently almost done reading up on the interchange protocol, and I'm glad that I looked into this because now this is something that I can look into anytime I come across any data visualization or any data science library in general. Because previously, what I was thinking about, and that's kind of why I think that's how I got onto this topic of like, okay, in so for Matplotlib, I would be able to pass in a pandas data frame. But for like, what about Polar's support? Basically, there's pandas support in Matplotlib. What about Polar's support? And then I explored, all of this stuff. And now that I know about the interchange protocol, I would need to look for interchange protocol support in whatever other library I'm looking for. It's not like I'm planning on exploring other data frame libraries. If I ever am, then like yeah, it'll be a huge bonus if interchange protocol is implemented. But Any other libraries that I'm exploring that are going to be using data frames, I would just need to check and make sure that they implement the interchange protocol, and then I can easily use polars with them. Now, what was I going to look for? There were a couple of questions that I had. So, first off, just need to clarify something to generate plots. Okay, all right. Then, what else? I'm completely blanking on the questions that I had. I had a certain, I had a doubt that I had to clear up. I can't remember what it was. Um, okay, two pandas and oh yeah, okay. So, continuing the conversation I was having with Gemini, instead of worrying about the low-level memory, just keep these two practical rules of thumb in mind as you build your Polars plus Altair pipelines. Keep things clean. You don't need to litter your code with dot two pandas anymore. Just pass the Polars data frame directly to Altair. And two, watch for materialization. In Polars, you will often use lazy frames using dot lazy to optimize performance. The interchange protocol requires the data to actually exist in memory for Altair to draw it. Altair to draw it. So you will need to call dot collect on on a Polar's lazy frame before handing it off to Altair. All right, okay. You know what? So we have like the basic polars data frame set up here. What I could do is um we can explore this. Actually, okay, another question that I had. I think we can move on from this now. Hey, I'm gonna be learning the Altair uh, DataViz library. It mentions that it uses a Vega light sort of syntax. I have no idea what that is, so understand. Um, I don't understand what's going on. Okay, welcome to the world of Altair. It is it is a fantastic library, but if you've never run into Vega Lite before, the syntax can definitely look like a weird abstract alien language at first glance. Don't worry, it's actually based on a really beautiful concept. Let's break down. Okay, all right, fine. The big idea. Say what you want, not how to draw it. Most traditional plotting libraries like matplotlib and Python are imperative. That means you have to give the computer step-by-step drawing instructions. Draw a canvas of this size, put a point at X and Y, color it blue, add a legend here. Altair and Vega Lite are declarative. Instead of giving drawing instructions, you describe the relationships between your data and visual elements. You say, here is my data frame. I want the age column on the x-axis, the salary column on the y-axis, and I want them represented as points. Vega Light takes that description and does all the heavy lifting of figuring out the math, scales, and pixel positions for you. Okay, what is Vega Light? Vega Light is a high level visualization grammar created by the University of Washington Interactive Data Lab. It uses JSON, a text based way to store data structures, to describe charts. Altair is simply a Python wrapper for Vega Lite. Okay, when you write Altair code in Python, okay, I guess this also explains why I remember reading somewhere that apparently these visualizations that you're describing, they can be exported as JSON. I didn't fully understand how it was going to be represented, but I guess this is how. Um, when you write Altair code in Python, all you are doing is using a clean Python syntax to generate Vega Lite JSON to generate a Vega Lite JSON file behind the scenes. Your browser then reads that JSON. Your browser then reads that JSON and renders a beautiful interactive chart. Okay, that's interesting. Okay, the three pillars of Altair slash Vega Lite syntax. Every time you build a chart in Altair, you will almost always use the exact same structural recipe. If you memorize these three pieces, the syntax will suddenly click. The data. You start with your data set, usually a pandas data frame. Okay, alt.chart, your data frame. Okay. Then the mark, which is the how. What is the first thing? The first thing is just the data. The second is the mark. You tell Altair how you want to visually represent the data points. Are they circles, lines, or bars? So mark point is for scatter plots, mark line is for line charts, mark bar is for bar charts. Okay. Then the encode, which is the what. This is the heart of Vega Lite. Encoding means mapping a column in your data set to a visual property called a channel on the screen. So map column A to the x-axis, column B to the y-axis, and map column C to the color of the points. Okay. Then putting it together, a quick comparison. Look at how neatly the structure maps to actual code. Imagine we have a data set of cars with columns horsepower, miles per gallon, and origin. Yep. Okay. The syntax looks pretty neat. It's the oh, it's basically this is the what do you call it? This is the example that Gemini just gave me. And hold on, this is great. We apparently have uh, some data sets available. Hold up. Um, Altair dot. What was it? Hold. Wait. Altair dot data sets. Okay. So I'm supposed to be looking for. Okay, it's not in. Oh, maybe it's here. Yeah. Maybe it's here. It is apparently not here either. So let's just search data sets. There. That's what I'm looking for. Um, Dataset schema wrapper, copy from so and so. There was in the example, what did the example show? From so and so import data and then data.cars. So here we have a data, Altair.datasets. Okay, let's try. Oh, oh God. Give me a second. I accidentally hit my I accidentally hit the control key on my keyboard and the key just went flying. Fortunately, it didn't break, so I was able to just put it back in. Okay. Anyways, um, I didn't pay attention to whether like where the spring was. I think the spring was inside. Okay, that's fine. So let's look at data source, I guess. Okay, Altair dot uh, data sets. That's the class. Okay, datasets dot data. Why did that not pop up, or why did that not show up here in this list? Am I missing something? I might be. Okay, all right. Import data, and then, dude, exploring this API is not. It's not helping too much. Okay, default engine pandas, datasets. Can I change the datasets.load, datasets.data? Dude, okay, exploring this API is not really helping me too much. Hey, in Altair, how do I load the inbuilt datasets? Also, can I load them as polars data frames? Also, what options do I have for datasets? Let's try looking at the user guide. Maybe in the user guide it mentions large data. No, not this. Encodings, data transformation, saving Altair charts, specifying data. Um, okay. Wait, they have data transformations as well. That's interesting. Okay, times and dates. Okay, interactive charts. It does not seem to be talking about the example data sets. Oh, also, this is interesting. It mentions, okay, there are many different ways to specify a data set. You can also specify it as a GeoPandas geodata frame or as shapely geometries. I need to look into what that is, or as GeoJSON objects. Okay, right. How to load inbuilt datasets in Altair. Altair includes built-in access to the standard Vega datasets. You can access them directly from the Altair datasets module or by calling the underlying downloader. To fetch the data as a usable table structure inside Python, you invoke the dataset name as a function. Okay, can I load them as polars data frames? Yes, absolutely. By default, calling so and so function returns a pandas data frame. However, since Polars natively integrates with Altair, you have two options to work with Polars. One is convert the inbuilt dataset to Polars. You can pass the pandas data frame straight into pl.dataframe. I forgot that was an option. I actually forgot that was an option. And two, use the Polar's native plotting API. So df pl plot.point. Okay, that's actually another thing I need to look into is how, because I got to Altair through Polars, right? In the visualization guide, it mentions various ways of plotting, and it mentioned here built-in plotting with Altair. I believe got that's how I first started exploring Altair. Um, it says here Polars has a plot method to create plots using Altair, and then we just specify all of the other information. All of this stuff, I guess I'll find this out later on once we actually explore Altair. Um, what was the first option? It was to do that and then alt.chart. Okay, yeah. So then we can just pass in the Polar's data frame directly into the chart method. All right. Okay. You know what? I think that's going to be it for today's stream. We're going to stop this right here. I am excited to explore this further, and I am kind of getting that spark back again of, you know, um, exploring polars. And now, additionally, I want to explore Altair as well. I need to, off stream, I need to finish that. I need to finish learning the sub process run thing. I need to finish the silence removal tool within my content pipeline. I also need to finish the Git branching stuff, which I think we're going to be doing the Git branching stuff more like in the next stream. I'll see. Let me decide which one I want to do on stream more. Do I want to do Polars plus Altair on stream, or do I want to do more Git stuff on stream? Um, I'll see, because both of them are equally important, and there's a bunch of information in both of them that I need to, like. I mean, the Git stuff, it's I have to read through all of that, um, but there's good reason for that, because I need that knowledge, I need that information. That's why I'm reading it. And then once we are done with that, I'll be exploring tagging for a little bit, and I'll see how tagging fits into the Git workflow. And then I'm done with the Git stuff. That's about all the basic knowledge that I need of Git, and that's about all I need in order to be able to, use Git in my daily workflow. And the great news is that I'm already using Git in my daily workflow. So a lot of the stuff that I've seen that I don't yet know how to make sense out of, like remote tracking branches being fetched and branches being merged, and being able to push branches and stuff like that. All of that stuff will make a lot more sense to me after I've learned it. And then we can continue with one of the many other things that I was doing. We'll be done with this thing. We can get this off the list. And then there's the West term thing. Actually, I have two of these items. I can get rid of one of them. There's West term mentioned twice. Then I need to continue working on the knowledge base tool, the dot files tool. I'm actually, like, right now I am working on it. And now that I have the knowledge of what do you call it? Now that I have the knowledge of inquire and clap, I'll be able to finish both of these. We are currently also working on the pipeline. And finally, we're going to be getting back to Impl Rust for ESP32. Polars is already in the list. AI low level studies, high level studies, that's going to come. That's going to come soon. Analog, I need to pick this back up. I was reading that Forrest Mims book, which was really interesting, and I was getting to learn a lot about analog electronics. So I definitely want to pick that back up. All in all, I think I'm doing a good job with keeping up with this list that I've made, and I'm very confident that this time I'm actually going to be getting hopefully all the items off the list. Maybe not these last two items because the last two items they involve a lot of other things. I don't intend to get them off the list. It's just to like I intend to get busy with these topics. Polars is gonna kind of contribute to being able to do AI stuff in addition to the data science stuff that I'm planning on doing. But yeah, that's going to be it for today's stream. Zanar, thank you very much for stopping by. Thanks for hanging out. Anyone else who might have been lurking in the chat, thanks for hanging out. I don't think I'm going to raid anyone today. I'm just going to end the stream here and go get something to eat and then continue with all of this research. I guess I can add Altair to the list now, right next to Polars, I guess. Um, yeah, that'll be the only addition to the list. But yeah, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.